Good morning, ladies and gentlemen, boys and girls, friends and neighbors. So let's talk about some polynomial functions. And in class, we're going to use the same definition of polynomial functions. We're going to talk about the graphs of polynomial functions in class. But during this video, we're going to talk about evaluating polynomial functions. So the first thing we need to do is talk about what in the world is a polynomial function of one variable. We've talked previously about polynomials in two variables, a and b, x and y. So when we talk about polynomial functions, the first thing to remember is we're only going to talk about polynomial functions in one variable. So here's the definition. We're going to let a, b, c, d, and e all be real numbers. Could be any real number. -5, 18, square root is 3, pi, whatever. And n is going to be a non-negative integer. The non-negative integers are these numbers here. 0, 1, 2, 3, ... These are the non-negative integers, also called the whole numbers. Just to emphasize that. Okay. So and a polynomial function is going to be of the form where here's your real numbers, a, b, c, d, and e. These are called the coefficients, as you well know. And n is the degree. These are the powers. So these whole numbers are going to be the powers of your variables. The exponents. The degree of this polynomial function is n, and a is the leading coefficient. So that's very important. So this guy right here, that's going to be the degree, and that's the highest power that you're going to see any variable raised to. And we're going to do variables x, one variable x, bam, 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 bam. The highest power that you see in the x2, that's the degree of the polynomial, and the rest of the exponents are going to be less than that. Well, look at this definition. Oh, n, what's n minus? Well, then is 2. N minus 1 is 1. And then 2 minus 2 is 0. And can you have a power of 0? Yes, you can. X to the power of 0 is 1. Okay? So let's just get into some examples and not get all bogged down in this seemingly difficult definition when it really isn't. Looks kind of funky, but we have to give you the real mathematical definition. The degree of this polynomial, we already talked about n. And so here's an example of a polynomial function. I have f of x, 5x to the 6th plus 7x cubed. Well, what happened to the x to the 5th? The coefficients to the x to the 5th and x to the 4th, those were 0. So all I really want to know is the degree, the leading coefficient, and is it a function of one variable? Well, I only see x's, so yes, bam, it is a function of only one variable. The degree here is going to be, it's the highest power, the highest exponent is 6. That's the highest exponent. The leading coefficient, abbreviated, is the real number in front of the term with the highest degree, in this case, 5. So the leading coefficient is 5. And the degree is 6. And example number 2, g of x. Oh, what the heck? What the heck? Is it one variable? Yes, I only have x's. Good deal. Why that little red mark there? I didn't know. I only have x's. So I need to know the degree. Degree here, is 4. The leading coefficient, the number in front of the term with the x to the highest power, -2. Easy peasy, lemon, daggone, squeezy. Okay, here's examples of non-polynomial functions. Well, they only have, wait a minute, it only has x's, that's okay. It has x's, but is it a polynomial? Well, look at this. What is square root of x? Square root of x, and I'm not sure if we've talked about that or not, that's the same as x to the 1/2. Is 1/2 a whole number? No. So this is not a polynomial. Not a polynomial. And why isn't f over here? Oh, I got all one variable. Oh, only x's. But check it out. Look at this exponent here. Look at this guy right here, x to the negative 3. This is not a polynomial because negative 3 is not a whole number. So this is a nope on the polynomial end. This is not a polynomial. Okay? So what we're going to do now that we know what a polynomial function is we are going to evaluate, find some points on some polynomials. We're going to find some specific points on a polynomial given the input. And we know what a function is, an input and output, input and output. The input here is going to be x because we only have one input. The input is x. The output is going to be a y, hello, which is also going to be a particular function value at a specific x. So let's evaluate the following and name the point represented by the equation. So let's find f of negative. Let's slow down. Okay, I will. F of negative 1. Well, you can always pause the video. Okay, so what I'm going to do, and keep in mind this is f of x, I'm going to put negative 1 in wherever I see an x. So this is going to be 4 times negative 1 cubed plus 5 times negative 1 squared minus 4 times negative 1 plus 3. Boy, I almost didn't have enough room. So let's evaluate that. Negative 1 cubed is negative 1 times 4 is negative 4. Negative 1 squared is 1 times 5 is 5. Negative 4 times negative 1 is 4 plus 3. Oh, look. What is negative 4 plus 4 is 0. 5 plus 3 is 8. So f of negative 1 is equal to 8. And what point then is on the graph of this polynomial? We're going to talk about the graphs of the polynomials in class, not in this video. So what point is on the graph? Bam, x, bam, y. Example number 2, let's find f of 2. How do I find f of 2? Well, wherever I see x, I'm going to put 2. So f of 2 is going to be 4 times 2 cubed plus 5 times 2 squared minus 4 times 2 plus 3. Now we're going to evaluate it. 2 cubed is 8. I have 4 times 8. 2 squared is 4. I have 4 cubed. 5 times 4. Negative 4 times 2 is negative 8. Plus 3. 4 plus 8 is 32. Plus 20. Minus 8. Plus 3. And I can do that however I want. So this is going to be 52 minus 8 plus 3 is going to be 47. So f of 2 is 47. And what point is associated with that? 2, 47. Okay, fairly straightforward. Let's go to another example. Alrighty. Oh heavens. Here I have evaluated polynomial at arbitrary x values. An arbitrary x value is the x is not specific. It's arbitrary, like a. F of a, how do I put a in? Well, of this function, wherever you see x, put a. You mean this is a cubed minus 2a squared plus 4a plus 3. Yup. That's it. So evaluating polynomials arbitrary x values, it's pretty straightforward. If you wanted actually to write the point, it would simply be a cubed minus 2a squared plus 4a plus 3. Bam, your x and your y. X, comma, y. Okay? What about f of 2a? What? F of 2a. So let's be very careful here. F of 2a, wherever I see x, I'm going to put 2a. So this is, and it's a good idea, wherever you see your x, put parentheses and put 2a in. Cubed. Wherever you see x, put your, don't forget the 2, put parentheses and put 2a in. Squared. Wherever you see x, put parentheses and put the 2a in. Plus 3. Now I'm going to evaluate that. Oh, laws of exponents. These are easy laws of exponent problems, by the way. 2 cubed is 8. 8a cubed. This is negative 2 times, 4a squared. We're going to simplify that even more. 4 times 2a is 8a plus 3. I have one more step here. 8a cubed minus 8a squared plus 8a plus 3. And that is that function evaluated at 2a. If I wanted to write the point associated with it, I could. And it would simply be 2a, comma, 8a cubed minus 8a squared plus 8a plus 3. Keep in mind, for this particular problem, what we're mostly looking for is f of 2a, which is equal to, indeed, this output if you put 2a in. Okay? Good examples of that. And so now, if you look at the next example, if you look at example number, whatever number it is, now we're going to consider this polynomial function 2x squared minus 2x plus 4, and we're going to evaluate the following, x minus, People get confused. Don't be confused. This says, all this is asking is wherever you see x here, put x minus 1. So you're going to do the parentheses method. So this is going to be, I'm going to write it down here so I have plenty of room. This is going to be 2 parentheses squared minus 3 parentheses plus 4. And what's going to go on the parentheses? X minus 1. And so we have to be very careful here. We have to do order of operations. And the first thing I have to do is find x minus 1 squared. So this is going to be 2 times x minus 1 times x minus 1. We can distribute this because there is no power here. This is going to be negative 3x plus 3 plus 4. And before I multiply by the 2 on that first term, I'm going to multiply the x minus 1 squared, and this is going to be 2 times x squared minus 2x plus 1. That's what x minus 1 times x minus 1 is. Don't forget the minus 3x plus a lot of steps, Lee. Yes, there is, Lee. A lot of steps here. So I'm going to use the distributive property here, multiply through by the 2. 2x squared minus 4x plus 2. I still have a minus 3x. I still have a plus 3. I still have plus 4. And now what we're going to do is simplify this bad boy. And I only have 2x squared. I have one term with x squared, and it's 2x squared. I have a negative 4x and a negative 3x. That's going to be minus 7x. And if I had 2 plus 3 plus 4 is, what is that? 5 plus 9. So that's what f of x minus 1 is. So f of x minus 1 is equal to 2x squared minus 7x plus 9. And this time, we're not really going to write it as a point. I mean, let's. We've done it on every other one, so let's just write this as a point, and we'll see this is your x value, and this is your y value. And that is a point on this particular function. What is that function? 3x plus 4. That was my original function, and this is that function evaluated at x minus 1. So not too awful bad. So let's do one more example, f of a squared, and I think this is going to be a little bit easier. This guy right here, what are you going to do? You're going to put a squared in wherever you see x. So let's do, this is going to be 2x squared minus 3x plus 4. And what's going to go in there? This is going to be 2 and what goes in there is a squared. A squared. Simple laws of exponents here. What is a squared is going to be a to the 4th, so that's 2a to the 4th minus 3a squared plus 4, easy peasy, much easier than this other rascal. And so what's the point? The point is going to be a squared, comma, 2a to the 4th minus 3a squared plus 4. So, quick video. These are going to be some examples that will help you on the assignment. All we did today was evaluate polynomials. We talked about what a polynomial function was, or what a polynomial function is. And what is a polynomial function? Polynomial function. And we're only talking about polynomial functions of one variable. The variable is going to be x. The powers of x are going to be whole numbers. And the coefficients are going to be real numbers. They could be anything. Okay, and we talked about degrees, leading coefficients. Talked about examples of non-polynomials. And then all we did was find specific points on a polynomial. So easy enough little video, short little video. And I will see you soon.